What I'd like to do now is do one more important follow-up to the example we just looked at. Specifically, I want to ask, are the results we got reasonable? So I've summarized over here the results that we previously got. We found that in this scenario, Apollo had measured a time of 1.2 hours between event A and event B, Starbucks departure and arrival. We found, of course, as set up, Apollo measured no distance between those two events. And in the fleet reference frame, where President Roslin and the Galactica were flying at constant velocity relative to the space station, we found that the delta t measured there, the coordinate time measured in the fleet reference frame between events A and B, was 1.3 hours, and the distance in the fleet reference frame was given as 0.5 hours. So we want to know, is this reasonable? Are these the results we'd expect? Well, we know, for example, that in relativity, a moving clock, if you're at rest and you see a clock moving relative to you, that moving clock will tend to will look like it is ticking slower than your own clock is. So it's very reasonable that the Galactica, for example, looking at Apollo's clock, would say, oh look, Apollo's clock was ticking too slow compared to our reference frame because Apollo was in motion. Remember, from the Galactica's perspective, Apollo on that space station is whizzing past the Galactica, which is at rest. And so they see Apollo in motion, and Apollo's clock is running slow. That's exactly what we'd expect. Good sign. The question you might ask is, why shouldn't we be worried that it doesn't work the other way? Apollo measures 1.2 hours, so shouldn't it worry us that from his perspective, the Galactica is moving, and yet that clock, that reference frame, measures 1.3 hours? Isn't that a problem? Well, turns out that indeed Apollo will see the Galactica's clock moving slower, but this has to combine with the other fact about clocks and relativity that we've studied, namely that clocks and relativity in a different reference frame aren't synchronized. That are synchronized, if you have two clocks that are synchronized in one reference frame, they won't be synchronized in another one. So let's be very explicit about that. Let's imagine that the clocks on President Roslin's ship, Colonial 1, and on the Galactica have been synchronized at some point. Just for instance, let's say that at some point leading up to this, someone sent a message from the midpoint of the two, where the two think they're sitting still as a fleet. Someone sent a message from the midpoint of those 2 points and sent a message to both of them at light speed saying, set your clock to time equals 0. That's a way of synchronizing 2 clocks. It works great. From Apollo's point of view, we've seen previously that those clocks won't seem to be synchronized. In particular, the clock that's in front will seem to read a time that is ahead of the clock that's in back. Let's see really quick where that comes from. Imagine, here I've drawn a space-time diagram of this whole story, and so you can see this is from Apollo's perspective. So Apollo's world line in this space-time diagram is straight up the vertical time axis, and the Galactica and Roslin are moving at the same constant slope to the right in the plus x direction. So if they wanted to synchronize their clocks at some earlier time, let's just say they wanted to synchronize the clocks so that this moment was time equals 0 when Roslin passes event A, passes the space station, and event A happens. If we wanted to synchronize the clocks for that to be time equals 0, we would need to find a point midway between the two, so along this line, midway between the two, where we could send a light beam from here up to Roslin's clock to say set time equals 0, and at the same time, 45 degrees, light beams always go at 45 degrees, or radio, or whatever. Same time, we send a message saying to the Galactica, set your clock to time equals 0. This means that from Apollo's point of view, the clock in front has been set to a later time, and the clock in back has been set to that time earlier. So, in other words, there's this difference in synchronization in Apollo's frame relative to the perfect synchronization in the Galactica-Roslin fleet frame. What's the effect of this? How did this make our answer make sense? Well, here's the deal. Apollo is still going to think, in his reference frame, he's still going to think that the clock on the Galactica is ticking slow. That's his expectation, that the Galactica's clock is ticking slow. And Apollo will measure in this point between the moment that Apollo started measuring at event A and the moment that event B happens. From Apollo's perspective, in that time, he'll see about 1.1 hours on the Galactica clock. Sure, and that 1.1, it's the same ratio. 12 over 13 is pretty close to 11 over 12, so he's going to see about 1.1 hours in that same time. So he will see a smaller time pass, but he also thinks that the Galactica started their time equals 0 timer too early. So he'll see an extra time. From Apollo's perspective, he'll think, yeah, sure, the Galactica's clock is running slow, so they would normally measure a shorter time, but for some stupid reason they started measuring too early, so of course that's why they got this 1.3 hours instead of the 1.1 they would have if they started measuring at the right time. That's the idea of how Apollo's perspective on this, it does make sense, and it's more complicated. It's much easier to do the double check when you're checking that a single observer's clock ticks more slowly. When you have to compare clocks from two different observers, as we do in the Galactica-Roslin fleet frame, when you have to compare two clocks, you always need to keep in mind not only the fact that clocks will run slower if they appear to be in motion, but also that those two different clocks will appear to be missynchronized. They won't be reading the same times at the same times from your perspective. And you need to account for both of those things to get up to that 1.3 hours that Apollo will that the Galactica reads from Apollo's point of view.